Hi everyone, I start with topic number one. Topic number one is functional notation. So before functional notation, I want to just talk about function. What is function? Functions are equations that you substitute a value, which is a constant value, into a variable, and then you find a result for another variable. Okay, for example, you have one input, and then it gives you, the input gives you another, an output. Okay, so maybe I can talk about a relationship between, for example, two values. For example, if I have just one value as just x, for example, which goes to two values, okay, this is not a function. Okay, this is just a relationship. What do I mean here? Okay, so I can go to review number 3 and show you here. Look at here. X, for example, equal 1, okay, x equal 1 is showing you two y's. It's showing you two y's. Okay, so this is not a function. This is just a relationship between x and y. This is an equation. Yes, x squared plus y squared equal 4. That's an equation, but it's not a function because 1x is giving two y's. That's not a function. Okay, but if I have, for example, two different x, which is here, is giving me just one y, okay, which I'm going to show you shortly, this is a function. That's not a problem. Okay, this is just a kind of function that if you go to, for example, further you continue in mathematics, you can see different kind of functions and those things. But this is a function. So if I have one x, okay, going to two y's, like here, okay, this is not a function. This is just a relationship. Yes, this is an equation, just a relationship between x and y. The relationship says x squared plus y squared is 4, but not a function. Okay, so for example, I can show you one function here. So this one, y equal x squared. Okay, so you give value to x and the result is x squared. Okay, look at the value here. See, two different x, which is like, okay, I can change the color like this, two different x, like this one and this one. Okay, so because it changed the color, maybe I can just do this. Okay, so one this here and this one here. Okay, two different x. Okay, look at these two different x. Okay, is giving you one y. Okay, so just one y. So I change the color here. Okay, so doesn't matter, this is a function, that's okay. Okay, so I just want you to know these things, so before I start to talk about function notation. Okay, so here I talked about what is a function, what is not a function, and so I show you example of this one, which is here, an example of this one, which was on the previous lesson, so the last example. So review number 3, the last page. Okay, so now I continue here. How can I say something is function or something is not? Okay, so if you just have the, for example, if you just have the equation, okay, it's not easy to say something is function or not. Okay, even here you have something easy because when you substitute one, you can find two y's and you know it's not a function, it's just a relationship. Okay, so that's not easy if I just have the equation. But if I give you the graph of the function, you can say is it a function or not a function very, very easy. How? Okay, you start to move a vertical line. You start to move a vertical line just over the graph of the function. And if you see for 1x, even just for 1x, you see 1x, you have two y's. This is 1x, okay, which goes to 2y, y1 and y2, okay, which is here and here, y1 and y2. Then you can see, oh, it's not a function. Okay, because I have one x going to two y's. Okay, look at here. if I make a line here, which I'm going to make it and then remove it, okay, so if I make this, look at this, if I move this line, I see almost for all of x, okay, just except 2 and minus 2, for all of x you have 2 y's, and that's not a function, this is just a relationship. Okay, I want you to know the definition of that, okay, definition of the function. Now I talk about functional notation. Okay, functional notation, I use y equal fx. Okay, this is a very common functional notation that we use. I want to talk about this here. Okay, when I say y equal fx, it doesn't mean f multiple x. No, this is not f multiple x. F is not separated from x. No, I cannot separate x from f. No, I just substitute x in an equation and I find y. So x is, for example, eaten by f. I cannot separate them. Okay, so if I say y equal gx, again the same thing, just I am using different I'm just using different notation. I can say y equal tx. Okay, means you have an equation. For example, you have x squared, x power 3 plus 5, okay, which is right side, and then you substitute x, you calculate and find y. You cannot separate f and x. You cannot separate x from f at all, and it's not f multiple x. Okay, this is just a function. Y is a function of x, or I can say y is f of x. I can say y is g of x. Y is t of x. Okay, so what do I mean here? Maybe I can give you one example. If there is a function, then the notation of fa means you replace a for x. Okay, so look at this example. When I talk, it's hard to understand unless I show you one example. So this is example here. Okay, g of x is 9 minus 3x squared. Means whatever you give me, I give you a squared multiplied by minus 3 plus 9. Okay, so 9 minus 3a squared. So you give me 1. I give you 9 minus 3, 1 squared, which is 6. You give me 2. I give you 9 minus 3, 2 squared, which is 9 minus 12, right? So just once again. Okay, yeah. 9 minus 12, yes, 9 minus 12, so my handwriting, I know, very bad. Okay, 9 minus 12, which is minus 3, right? So, how about if I substitute minus 2? Okay, if I substitute minus 2, which is here, look at this, which is here, if I substitute that, that's the same thing, 9 minus 3 minus 2 squared, which is 4, this is 4, 3 minus 4 is 12, and 9 minus 12 is minus 3. Okay, is it a function? Yes, that's fine, because two different x goes to the same y, which is the same as previous page, and that's okay, that's a function. Okay, if I see one x goes to two different y's, that's not a function, but here is opposite. Okay, two different x, the same y. Okay, that's a function. So if I give you a function, so means right side you have several operations. For example, you squared, you multiply by minus 3, you add 9, so several operations. I give a value, you substitute for x, and you calculate, and you give me the output. So here minus 2 is input and minus 3 is output. It's like a factory. I show you here, it's like a factory. So I showed you in the, so it was in the previous review, so maybe I can go here and show it to you. So at the beginning of the lesson, I think it was there. Okay, look at this. That's like a factory here. Do I have it? Yes, look at this. See, it is like a factory. I'm giving you, so okay, see, this is like a factory here. I'm giving you x, and the result is x squared. So whatever I give you, the result is x, just s squared of that. So that's input and output. Okay, so we saw this, and that's the equation. Okay, so now another example. I have hx equal x cubed minus 2x plus 1. So whatever I give you, you cube it, you do minus 2x, and you add with 1, and you add all of them, okay, with 1. Okay, so what is the result here? What is the result here? Okay, so if I do, what is the result here if I do a function 2.55? Okay, so means h 2.55. It doesn't mean h multiple 2.55. No. Okay, so 2.55 power 3 minus 2 multiple 2.55, okay, plus 1, right? Okay, maybe I can say this is approximate. I have to tell you this is approximate, and I can say these are exact. You have to know these are exact. Okay, so then I would say, okay, let's round it. Okay, so how do I round here? Okay, so this is 3 significant digit, okay, power 3. It's like 3 significant digit multiple 3 significant digit multiple 3 significant digit. So you round it to the least significant digit, which is 3 significant digit. So then you have to think about this. Okay, so this is 3 significant digit, that's exact, so you round to 3 significant digit. Okay, 3 significant digit, 3 significant digit. Then you have subtraction. Because you have subtraction, you have to think about the least decimal place. Okay, so you have to see how many decimal place you have. Okay, if you have 3 significant digit, how many decimal place you have? So you do 2.55 multiple, so cube. Okay, so cube here, which is 16.58. Okay, so this gives you 1 decimal place. Remember, you are not rounding it. No, you are not rounding it. You are using the same number. Okay, here you have, if you want 3 significant digit, you have again 1 decimal place. Okay, and you have to round to 1 decimal place. Okay, so let's find the answer. Okay, I find the answer, all of the answer here. Okay, so the answer is, I keep this answer here, minus 2 times 2.55 plus 1, which is 12.48. That's 12.48. Okay, we can practice rounding as well as just finding the answer. I underline that, check that, it is almost 12.5. Okay, but if I don't say anything about approximate, no, you just calculate and show me several digits. You don't need to be worried about rounding appropriately. Okay, so if you have a function, for example h of x, you cannot say h multiple x, you cannot separate, you substitute value for x and you find the result. Then 2.55 is not, it doesn't exist anymore. So because it's calculated, it's used to calculate the output, and I just have the output. Okay, so another example which is like just like a word problem. The resistance R of a conductor is a function of temperature. Okay, so I can say so the function of temperature, so I can say, okay, f of t is R0 multiple 1 plus alpha t. Okay, in this case I need to say what is R0. So R0 is resistance at 0 Celsius, and alpha is the temperature coefficient of resistance, which I can use this here. Okay, so if the resistance of a copper coil is this, so find the result here. So this is, okay, so this one is R0. Oops, I did the question, I understand what's going on. Okay, so let me see if I can make this guy to work. Okay, so this one, and oops, okay, the alpha is this. Okay, so that's 9800 multiple 1 plus alpha. Okay, so alpha is 0.00427 t, okay, and then you have to substitute t, 427 t. Okay, now it says substitute t, so you substitute t equal 20.0, you substitute t equal 25.0, you substitute different values for t because that's function of t, f of t. So t is changing, ft is calculated, okay, t is output, input, ft is output. Okay, so you just calculate, you just substitute this here. So for example, for f of 20, okay, is 9800 multiple 1 plus this multiple this one here, okay. So yeah, so I just multiple the alpha with t, okay, and then I add with 1, and then I multiple the result with 9800. Okay, so now I continue here. I can okay, so how about that if I do f 25.0, so I just substitute 25 for t. Okay, so now I can write maybe, okay, so the answer here. Okay, so for f of this one, the result is this, and I round to 3 significant digit because of this, because of this one. So I change the color maybe to green, so because of that and that 3 significant digit. So then I underline that, I check that this is 106,000, okay, and the other one, so f of 25.0, you can calculate on your own, so you can see it is 108,000, and f of 30, okay, is 111,000. Okay, so you find the answer and then you round it, round it. So when you are doing a word problem, be careful about the answer, be careful about rounding appropriately, and be careful about the unit. So what is the unit? Okay, so here what is the unit? So we are calculating, see, it says we are calculating the resistance. Okay, so here this, okay, so it's going to be O, right? Okay, so now we continue here for these examples. Okay, so let's see this. That's a very good question. That's a very good question here that I can do it for you. Okay, so this one I want to emphasize, this f minus 2c doesn't mean minus 2 multiple fc. No, you cannot bring 2 out. It doesn't mean f minus 2c is not f of minus 2 multiple f of c. No, you cannot separate. Okay, minus 2c is like a new value. You substitute for x and then you calculate it. Okay, so do you put minus 2 for x? No. Do you put just c for x? No. Okay, you do minus 2c for x. Okay, so now find the answer. Okay, it is 5 minus 13 multiple minus 2c, which is 5 plus 26c. Now I don't know what is the result as a value because I don't know what is c. Okay, but still I can simplify, I can substitute, and I can know that I'm not able to separate them. I'm not able to bring minus 2 out. No, it's not. Okay, so this is not equal, this is not equal this is not equal this. I just have to substitute minus 2c. I just have to substitute whatever I see for x. Okay, so now I continue here. Okay, so f of x and y and z, so is 3z minus 2x plus y squared. So if you go to university and you just, for example, do bachelor or do engineering, you have mathematics 2, calculus 2, and in calculus 2 you have these kind of functions that you have several variables. So the function is like, for example, instead of 2 dimension is like 3 dimension. Okay, so it's not just, for example, or even more. Okay, so not just y and x, no, you have x, y, z, and then for example I can say w is f, x, y, and z. Compare this with y equal fx. So here I have x and I have y, so this 2 dimension. So compare, I should have x, y, z, and then I substitute and find the result for w. Okay, so what is the result here? Okay, I substitute 3 for x, I substitute 1 for y, I substitute 5 for z. I cannot change this, no, because that's the order I see. Okay, so it's 3 times 5 minus 2 times 3 plus 1 squared, which is 15 minus 6 plus 1, which is 9 plus 1, which is 10. Okay, 10 is the result. Okay, so this is just several notation. So just several variables which you substitute and then find another one. Okay, so how about this here? Okay, this is a very good question too. Okay, so you have fx equal 5. What does this mean when I say fx equal 5? Okay, so fx equal 5. Okay, if I have x equal 1, what happened? Okay, the result is just 5. Because I don't see any x, so the result is just 5. Okay, if I do 2, what happened? 5. Whatever I put for x, the result is 5. Because that's a constant function. Okay, so f of minus 2 is, so minus 2c is 5. F of 2 is 5. And f of 100 is also 5. Because that's a constant function. Okay, so now, okay, so let me just see something. Yeah, so I can continue here. So here, okay, let me see. Oops. Okay, multiple functions. Okay, I can do operations on functions. Okay, so for example, I can add functions, I can subtract functions, I can multiply a number with functions, or I can multiply 2 functions. I can do that. Okay, so if I have several functions, what should I do? I can combine them. Okay, so for example, here I have gx equal 2x plus 3. Means if I give x, it double it plus 3 and gives me back the result. I have hx equal 4x plus 5. Means if I give x, it gives me 4 times and add 5 and give me back. Okay, so now what is a? A is gx plus hx. Means you just have to add them. So it's 2x plus 3 plus 4x plus 5, which you need to do like terms, this one and this one. So it is 6x, oops, 6x plus 8. Okay, how about the next one? So the next one, b, is 2gx minus 3hx. Okay, so that's 2 times 2x plus 3 minus 3 times where is it? Yes, 4x plus 5. Okay, and then you can find the result. So it is 4x plus 6 minus 12x minus 15 equal minus 8x minus 9, right? And this one I can do it here. See, this one is gx multiple hx, so it's 2x plus 3, like one bracket multiple another bracket. Okay, so I do so like I multiply this with this, and then this with this, and then this with this, and then this with this. So it is 8x squared plus 10x plus 12x plus 15. Okay, which is 8x squared, this and this and this. So plus 22x plus 15. Okay, so that's the result for that. So I can add functions, I can multiple functions. Okay, so now I finish here, and because composite function is very important, I want to talk about it in another video. So this is end of video number 1, and I will continue after.